At 12:57 in the morning, the ground beneath the Malaysian state of Sabah suddenly shifted. Not a gentle tremor, not a brief vibration, but a powerful jolt strong enough to be felt by 78 million people across 5 countries. This was not just another earthquake. It was the strongest earthquake to strike Malaysia in 103 years, magnitude 7.1. But what stunned seismologists was not just the number. The epicenter was located 620 kilometers beneath the Earth's surface, deeper than almost any earthquake ever recorded on the planet. From the coastal capital of Kota Kinabalu to high-rise apartments in Singapore, 1,500 kilometers away, residents were jolted awake as ceiling fans swayed violently, picture frames rattled off walls and windows, trembled in the dark. Within minutes, global monitoring agencies, including the United States Geological Survey, confirmed the reading magnitude 7.1. And then came the most astonishing detail. No tsunami, no fatalities, no structural collapses. How could an earthquake this powerful cause no visible destruction? The answer lies more than 600 kilometers below our feet, where a vanished ocean basin from 16 million years ago may have just awakened. And if it can shake half of Southeast Asia from that depth, what happens next time if the rupture begins only 20 kilometers below the surface? At 12:57 in the morning, northern Borneo moved sideways. Within 5 minutes, seismic monitors in Europe lit up. Germany's research network issued the first automated alert magnitude, 7.1. Minutes later, Indonesia confirmed it. Then Australia, then the United States Geological Survey. The numbers aligned. The depth reading stunned everyone, 620 kilometers. In Kota Kinabalu, the shaking lasted roughly 10 seconds. Survivors would later say it felt much longer. A ceiling fan swung violently above a living room sofa. Glass cabinet doors clicked and rattled. Framed photographs tipped and struck the floor. One resident woke his wife and 3 children and rushed them down the emergency stairwell, barefoot into the parking structure below. On the 6th floor of another building, a clinic assistant finishing a night shift watched her wardrobe door swing open by itself. The windows trembled. She grabbed her mother a flashlight and her phone before heading for the stairs. On the resort islands of Manukan Island, Gaia Island and Sapi Island, guests reported beds shaking and wooden beams creaking in the dark. Beachfront operators guided visitors away from the shoreline while authorities assessed tsunami risk. And then the tremor crossed borders. In Singapore, nearly 1,500 kilometers to the southwest, residents in eastern districts posted online within minutes. Some described their apartments swaying. Others reported a loud bang at their doors. Reports streamed in from Brunei, the Philippines, southern Thailand and Cambodia. The earthquake had not only shaken buildings, it had connected 5 countries in a single moment of shared uncertainty, all waiting for the next alert, the next update, the next sign of whether this was over or just beginning. As reports flooded in from across Southeast Asia, one fear rose above all others: tsunami. A magnitude 7.1 earthquake beneath the sea typically triggers immediate coastal alarms, but within minutes, the Pacific Tsunami Warning Center confirmed something unexpected. No tsunami was possible. The reason was not that the earthquake was weak, it was that it was too deep. The rupture began 620 kilometers below the surface. At that depth, the energy released by the quake must travel through hundreds of kilometers of dense mantle and crust before reaching the ocean floor. By the time it does, much of that force has already dissipated. Tsunamis are generated when the seafloor itself is abruptly displaced, lifted or dropped, pushing massive volumes of water upward. But this event occurred far beneath the tectonic layers that directly shape the seabed. The ocean floor above Sabah barely moved. To put the depth into perspective, the earthquake's source was farther from the nearest human being than the distance between London and Paris, twice over. So, while the magnitude sounded catastrophic, the physics told a different story. This was a powerful earthquake, but it was trapped in the deep earth. Its most destructive force absorbed long before it could reach the surface. As the immediate danger passed, attention shifted from emergency response to something far more unsettling: the data. When seismologists traced the rupture beneath Sabah, they expected to see a familiar pattern: a known fault line, a mapped plate boundary, a predictable tectonic interaction. Instead, the signal pointed to something that does not appear on standard global models. The event did not originate along the edge of any recognized tectonic plate. It was not associated with a mapped subduction interface. Even more surprising, its source did not clearly match structures identified in the widely used Slab 2 reference model maintained by the United States Geological Survey. That absence raised a deeper question. What exactly ruptured 620 kilometers down? Some researchers propose that the earthquake may have occurred within a detached fragment of ancient oceanic crust, a remnant of the SAS, long-vanished Proto-South China Sea. Geological evidence suggests that this prehistoric ocean basin once separated Borneo from mainland Asia before being swallowed into the mantle roughly 16 million years ago. If that interpretation is correct, then this was not simply a deep earthquake. It may have been the reactivation of a slab of ocean floor that disappeared millions of years ago, a structure no longer visible at the surface, yet still capable of storing and releasing immense stress. In other words, the Earth may still be adjusting to tectonic rearrangements that happened long before humans existed. A vanished ocean, a missing slab, and a magnitude 7.1 signal emerging from a place our maps do not fully explain. For scientists, this was not just another seismic event. It was a reminder that parts of the deep Earth remain largely uncharted, and occasionally they remind us, at a depth of 620 kilometers, the rules of earthquakes change. Near the surface, earthquakes occur because brittle rock fractures under stress, fault lines snap, plates grind past one another. Energy is released in a violent break, but deep within the mantle, conditions are entirely different. Temperatures are extreme, pressure is immense. Rock at that level is not supposed to crack in the conventional sense. So how did a magnitude 7.1 earthquake happen there? The leading explanation is a process known as transformational faulting. Deep in the mantle, the dominant mineral is olivine. Under crushing pressure, olivine can abruptly change its crystal structure, reorganizing its atomic arrangement into a denser form. This transformation does not happen gradually. It can occur suddenly, cascading through surrounding material like a chain reaction. Instead of rock shattering, the rock restructures itself. That structural shift releases stored elastic energy, generating seismic waves indistinguishable from those produced by a traditional fault rupture. The difference lies in the mechanism. No classic fracture, no surface-breaking fault, just mineral physics unfolding under conditions humans can barely replicate in laboratories. Researchers studying deep-focus earthquakes have long debated this mechanism, but events like the one beneath Sabah offer rare real-world evidence. This earthquake did not tear the Earth's crust apart. It triggered a phase transformation more than 600 kilometers below our feet, a reminder that even solid rock under enough pressure can behave in ways that challenge our understanding of what solid truly means. The magnitude 7.1 earthquake that struck 620 kilometers beneath Sabah did not cause destruction. But the deeper scientific story reveals a far more uncomfortable truth. The true danger in this region does not lie in the deep mantle. It lies much closer to the surface. Sabah sits at the complex junction of three major tectonic plates, the Sunda Plate, the Philippine Sea Plate, and the Indo-Australian Plate. Northern Borneo is threaded with shallow active fault systems, including the Crocker Fault, which runs near Kota Kinabalu, and the Mensaban Fault near Rano. These faults are far more dangerous than the deep slab that just shifted. A recent government-initiated vulnerability assessment examined more than 500 buildings across 7 districts of Sabah. Most were constructed during the rapid development boom beginning in the 1980s. At the time, Malaysia did not have a seismic building code. Structures were designed to withstand gravity loads and wind, not earthquakes. More than 160 buildings in Kota, Kinabalu and Kudat were classified as Grade 4 vulnerability, meaning they face potential partial collapse during a moderate shallow earthquake. Malaysia's national seismic building standard was only introduced in late 2017. Everything built before that date may lack proper earthquake-resistant design. The region's population has quadrupled since the last major shallow earthquake in 1976. So while the deep quake caused no casualties, it exposed a structural vulnerability that remains unresolved. If a magnitude 7 earthquake were to strike at a depth of 20 kilometers instead of 620, the outcome could look very different. The earth beneath Sabah is complex, but the buildings above it may be the greater uncertainty. For many in Sabah, the memory of what a shallow earthquake can do is not theoretical, it is personal. On the morning of June 5, 2015, a magnitude 6.0 earthquake struck just 18 kilometers beneath the surface near Ranao. Compared to the recent magnitude 7.1 event, it was significantly weaker, but its shallow depth made all the difference. When the ground shook, massive granite boulders broke loose from the slopes of Mount Kinabalu. Rocks the size of car tires thundered down climbing routes with almost no warning. At that moment, a group of students and teachers from Singapore were ascending the mountain along the Via Ferrata path. 18 people died. 6 of them were children. The tragedy reshaped how Malaysians viewed seismic risk. It shattered the long-held assumption that the country was largely insulated from deadly earthquakes. Memorials were built, names were engraved in stone. The disaster became a national reference point, proof that even moderate earthquakes when shallow can turn catastrophic. Nearly a decade later, 2 survivors returned to Mount Kinabalu to complete the climb they never finished. Their ascent was not just symbolic. It was a reminder that the mountain and the fault systems beneath it remain active. That is the contrast that defines the present moment. In 2015, a smaller, shallower quake killed 18 people. In 2026, a stronger, deeper quake caused none. The difference was not magnitude, it was depth. By mid-morning, markets reopened in Kota Kinabalu, fish vendors restacked their goods, traffic returned. Official statements confirmed 0 deaths, 0 injuries, 0 collapses. On the surface, the story appeared to be over. But beneath Sabah, nothing has fundamentally changed. The deep slab that generated the magnitude 7.1 earthquake is still there, suspended in the mantle. The shallow faults that cut across northern Borneo, including those near populated districts, have not released major stress in years. The region's building stock, much of it constructed before modern seismic standards were introduced, remains largely the same. So the real questions are forward-looking. If more than 160 buildings are vulnerable to partial collapse in a moderate shallow quake, what mitigation plan exists? Who is responsible for reinforcing older structures built before 2017, and how many deep tectonic remnants remain unmapped beneath Southeast Asia? The recent earthquake was a demonstration of geological complexity, but also of geological restraint. It showed what can happen when immense energy is released far below human reach. What it did not show is what happens when that energy is released closer to the surface. The shaking has stopped, the monitoring continues, and the faults beneath Sabah are still waiting. If you found this breakdown insightful and want deeper analysis behind the headlines, make sure to support the channel. Tap the like button so more viewers can understand the science behind events like this. Share your thoughts in the comments. Do you think Southeast Asia is prepared for a shallow major earthquake? And if you want detailed investigations into global disasters, tectonic risks, and the hidden forces shaping our planet, subscribe and turn on notifications. The Earth is constantly moving. Stay informed, stay prepared,